quick review for the octet rule. Just remember octet with octopus. Number 8. So what is an octet rule? It's a tendency of an atom to lose, gain, or share valence electrons to completely fill their valence shell with 8 electrons. So this is a key word here, valence, and valence electrons are very important when we talk about the octet rule. Here I have done the valence electrons. I have valence electrons. This is called the Lewis-Dart structure. And if you look here, the helium is actually happy. It's kind of not following the octet rule. It is happy. It's following like a duet rule, just 2 valence electrons. Rest of the noble gases all have 8 valence electrons. So what happens as a result of losing, gaining, or sharing valence electrons, all the atoms on periodic table, they match up their electron configuration with their nearest noble gas. Again, of course, there are exceptions. So, but in general, all elements on periodic table, they would lose, gain, or share valence electrons to be like their nearest noble gas. Because as a result, what happens? As a result of attaining a noble gas configuration, they become more stable. Why more stable? Because of the full octet, full valence shell. Well, that's what is with the noble gases. They have full octet, they are stable, they have full valence shell. So noble gases are the last group on the periodic table. Once again, here I have that group here, and they will not be participating in any bonding just because they are least reactive, they are unreactive, and there is another word called inert. And also the last group is called zero group. Okay guys, and let me see what else here. How about, so for group A group elements, where are the A group elements? Our A group elements are the one here on the left and on the right. Okay, so it's right here, it's on the left and on the right. They are also called representative elements. So for group for A group elements, as I just said, their group number is equals to the valence electrons. So here group 1, 2, 3 valence electrons, 4, 5, 6, 7, and 8. Now how many electrons will be lost or gained or shared? It depends on which element is it. Is it a metal, metalloid, non-metal? Okay, so here elements with 1, 2, or 3 valence electrons, actually these are the metals, and they lose electrons. So 1 valence electron, 1 will be lost, 2 will be lost, and 3 electrons will be lost. However, when you have 5, 6, 7, or 8, so 5 needs just 3 more, 6 needs just 2 more, 7 needs just 1 more to complete the octet, and these are actually the non-metals. So you're going to say here 3 gain 3, gain 2, and gain 1. Alright, now how about 8? Group 8 here, it's neither 0 gain or 0 loss. It's neither going to gain nor lose since octet is already complete. Well, we have another one here, 4. How about this one? So this could be 4 loss, or could be 4 gain, or it can share its valence electrons. Alright, so here this one is the most reactive, just because all it needs only 1 electron to complete the octet, so it's much easier. Here in group 1A, this one is the most reactive group. However, this just the same reason, because it has to lose only 1 electron. However, these are the metals, and here this is non-metals, which is halogens. I hope you got it, guys.